And good evening, morning, afternoon, ladies and gentlemen. How are you doing today? Welcome to another class. It's great to see you. Nice sunny day. In fact, I even decided to put on a tie today. It's been a while. I'm telling you, it's been a while. I was missing it, so I got all dressed up for the occasion here today. Because today we're going to talk about solving systems of equations using the substitution method. All right, thank you everyone. Thank you. Round of applause is not necessary, but it is appreciated. All right. I like to call it the replacement method, so that's why I put that in pink there. That's what I like to call it. But the basic premise of what we're going to do, we'll do all three of these problems, is we're going to have two unknowns, and we're going to have two relationships, because you need two relationships if you've got two things you don't know. And then what we're going to do is we're going to try to figure out the value of one in terms of the other variable, and then make the replacement. Okay, so we're going to try to get one equation that only's got one unknown instead of two unknowns. So I like to break these up in level 1, level 2, and level 3. So just real quickly, kind of looking over them, one of the things you might notice is like what I'm calling a level 1. Those are problems where you already have one of the variable isolated for you. That is cash money. That is really nice. If you're going to use this method, which of course you don't have to, there's other methods, but if you see this situation, you got to think to yourself, yeah, let me go get this replacement method. Level 2, I call it a level 2 because if you notice, it doesn't have one of the variables all by itself. Okay, it doesn't even have to be y, by the way. Could have been x, but in this case it was y. But one of the things you'll notice with level 2 is that one of the variables doesn't have a coefficient. So it's going to be easier to isolate. It's going to be less steps to try to isolate one of the unknowns in terms of the other one. And level 3, you'll notice every single variable has a coefficient. So this would be the most difficult one to do. This is the type that maybe you use elimination method as another option. But we're going to do them all with substitution, because substitution always works. So let's go get it. Let's go get level 1 first. Watch this. Oh my God, Mr. Miller, you prepared. You prepared, dog. You prepared. That's right. Okay, so what I'm gonna do, and I'm gonna switch the colors here. So let's make this bottom one red. I'm just rewriting it in red. We'll call this equation 1. All right. This one up here will be equation number 2. So what I'm going to do is I'm going to replace y in equation 2 with this value of y from equation 1. So here, that might as well be red. What I'm going to do is instead of writing y, I'm going to replace it with negative x plus 16. Because I know that the left side is equal to the right side, because that's what an equals sign means. All right. So let's do that step. We're going to go minus 4x plus 6. And so in there, I got my replacement. Yes, sir. Yes, ma'am. Let's do it. Let's do it. Okay, so then we got equals 16. So that's now this same equation 2. But notice there's only one variable. So now I can solve this equation using the same strategy we always use, which is to combine our variables, move all the numbers to the other side, and then divide it out. All right, let's go for it. Here we got, this is going to happen quite a bit with substitution, where you have to do the distributive property next. So let's do it. So what I'm going to do is I'm going to take this 6, and we are going to move that in. So we get minus 4x. Now positive 6 and a negative is going to give you a negative. So I'm going to write that as minus 6x. 6 times, oh my God, come on, 6 times 16? How are they going to do that to me? How are they going to do that to me? All right. Well, 6 times 10 is 60, plus 36 is 96. All right. Ooh-wee. Not expecting that one. All right. So let's keep it up. We've got to combine our like terms. So negative 4x minus 6 means you're going to have minus 10. And I'm going to move the 96 over. So by that I have to subtract it. All right, so then that's going to give me minus 80. 16 minus 96 is negative 80. Okay, you got $16. You borrow 96, you minus 80. All right, so now I'm going to divide everything by negative 10. Oh, dog's barking. Yeah, hey, no edits here. Negative 10 divided by negative 8, well, negative 8 divided by negative 10 is 8. And that is our value of x. All right. Are we done? Am I done? No, I am not done, because that's only one of the unknowns. Come on, people. There was 2 unknowns, so I got to go back and now I got to solve for y. So what I'm going to do, if this is, say, equation 3, I'm going to replace the value of x with an 8. And I can do it in either equation, but I think I'm going to pick this one. So what I'm going to do here is I'm going to say y is equal to negative, right, or the opposite. And in there, I'm going to replace x with an 8. That's the idea of replacement, right? So what do we got then? Is we got minus 8 plus 16, which is 8. Wow, they're both 8. I wonder if it's right. Like, I wonder if it's the right answer. I wonder. Let's check. Beautiful thing about mathematics, all we got to do to check is plug these numbers back into the original equation and see if they work. I can already see it is going to work, because 8 is going to be equal to negative 8 plus 16. So cash money. Let's move on. Boom. All right. Hey, moving on to level 2. So one of the first things we're going to have to do here with level 2 is we got to solve one of these equations for one of the other variables. So the reason I'm calling this level 2 is because this one here, if I make this y red, right, make it red, notice it's all by itself. So all I'm going to have to do, and what I mean by all by itself is it doesn't have a coefficient, is take the x and move it to the other side. So you can add 5x, right? Because if you add 5x, you'll get 0, negative 5 plus 5. And you'll have to do that to both sides. So I do like to number these equations. So I'm going to do in orange, because my red marker's not doing so good. Here we go. Boom. So let's go, let's give that one last hurrah for the red marker. Is equal to 5x minus 11. Hell yeah, that's how we do it. That's how we be. Because I added 5x to both sides. So plus 5x is 0. And here's my plus 5x now on the other side of the equation. All right, so now what I want to do is, if this is, let's say, equation 1, we'll make it red. All right, and this is equation 2. I'm not even going to flip the board. I think we got enough room to just rock this problem right here, especially if I borrow from this side. Let's do that. Okay. What I'll do is I'll replace y from equation 1 right here into equation 2. So this y value is the one I'm going to substitute it in. Well, let's do that replacement and see what we got. All right. Hey, whatevs. It's I barely know what day it is anymore these days. I swear they all feel the same. Equals minus 9. There it is. That's how we roll. All right then. Same as before. You're gonna have to solve this equation and replace it. So I'll do this quick time. All right, so there you go. You get 2 and -1. Look at that work. Hit pause if you want to analyze it. Didn't show all my steps, but hopefully I showed enough steps. 2 and -1. We should probably check our answers, so let's do that also fairly rapidly. Hey! Got it right! Feels good. It feels really good, actually. Even though I knew I was going to probably get it right, it still feels good. I'm still kind of stoked with that. All right, so of course it's right because I plugged in my values of x and y, and I got it that it equals -11. All right, let's get ready for level 3, the last level. All right, let's go for it. I left here level 1 because this is ultimately what we want, right? We want one of the 2 variables isolated. So here, we're going to have to pick and solve for either x or y. So a problem like this, you probably want to use your skills with standard form to try to avoid fractions. Avoid the fractions. Like, for example, if I come up here and I try to solve for this value of y, I'm going to have to do 11 divided by 2 at some point. So I'm going to set up a fraction. I don't want to set up a fraction. I'm also going to have to do 5 divided by 2. So when you've got something like level 3, my advice is to first sit back and try to figure out, like, which one am I only going to have integers to deal with. In this problem, nothing here on the top is going to have only integers because none of those numbers divide into 11. Here, both these numbers divide into 20, so that's a good sign. But when that happens here, I really want to take advantage and solve for y, because I would rather do 10 divided by 5 than 5 divided by 10. If that didn't make total sense to you, no worries. Let me just show you. So what I'm going to do is, let's just focus here on this equation, which I'll call number 1. I'm actually going to add 10x to both sides. And when I do that, that's going to get me that 0 I'm looking for. And then over here, I'm going to have 10x plus 20. So follow me. Let's go. You know where the train's going. Y'all know where that train's going. All right, so we got 10x plus 20. Hey, beautiful. Still not quite alone, but you can see what I'm talking about because I'm going to divide by 5, and here's that 10 divided by 5. Had I gone the other direction, right, and had I subtracted 5, I would have 5 over here, and I'd have to be dividing 5 divided by 10, and that would have given me a half. Not terrible, but not integer. All right, so let's divide all terms by 5, which I'll do with the beauty of the fraction bar. And we get y is equal to 2x plus 4. Boom! Holla! That's how we be. Now we're good. Now we're good. We're so good because we know that a y is exactly the same, not kind of similar, exactly the same to 2x's plus a 4. Do you hear what I'm saying? I'm telling you a y is exactly the same as 2x's and a 4. So this will become my new equation number 2. And I'm going to go to, I could pick either one, but I'm going to pick this one that I haven't used yet. And I'm going to replace this y value right here. It's kind of fun now. I'm like, ooh, little puzzle. I'm going to replace this y value with 2x plus 4. 2x plus 4. Because I know y is the same as 2x's and a 4. So now if I take this equation and you know, it's a little bouncy on the board right now, but I think you're getting the point, I hope. We're going to go like this. Ta-da! That's how we be. Now we got an equation with all x's, right? So that is something we can solve because there's only one thing we don't know. So I'm gonna solve that real quick. Okay, so you get negative x is equal to 3. So that means x is equal to negative 3. Last step, you know what's coming. In any equation that I've got, any one of these equations, I got to replace x with the value of negative 3. So I'll do that here. So I'm going to take this equation, number 1, and go negative 10x. And there's the move. There's the replacement. That's how we do it. Okay, feeling really confident right now. I hope this is going to work. We get 30 plus 5y is equal to 20. So let's subtract 30 and get 5y is equal to negative 10. So therefore y is minus 2. All right. Cue the music. It's in my head, really, I suppose. Anyways, you know, if it feels good, you can check the answers and see if they work out, and that's a beautiful thing. It's called solving by replacement. Hope you enjoy it. Hope you have fun with these. Try some more for sure. Look at all these colors I got. Straighten out my tie. Say, oh, you know, I used to listen to this radio show, and it was a sports talk show. And he'd always say, angels fly because they take themselves lightly. So there you go. That'll be the close today. Angels fly because they take themselves lightly. Take care.